to hear. All right, so welcome back to, welcome for the first time to the second CAD class. It seems like every person here was in the last class, so that's a great start. We don't need to go over like downloading Onshape. I guess not downloading, but creating an Onshape account or anything. So while we're here, take a moment to log into Onshape. Create a new part studio. We'll get into that in a moment after the introductory parts, but if you have any questions specifically about Onshape, feel free to ask, and I'm happy to go over that since I would have time to go over it anyway for the new students. I do see, okay, yeah, so for the students who just joined, I think you were in the previous class, you already have Onshape account, so just go in, log in as you usually do, and we'll get started. So this class, I guess I am the only instructor for this class, for this session of it. There is a Google Classroom, as there was for the last one, and this week, I guess for this course in general, I'll be uploading the slides each week, which is different from the previous class where I didn't really work from a set of slides. So you'll have access to everything you see in front of you here. So if you need to refer to it between classes, you're able to do that through the Google Classroom. I'll also be putting other files there that will be related to what you might need for the homework. So just keep that in mind. Make sure you can access the Google Classroom. If you need the code, hopefully I can put that into the chat for you. Whoops. There you go. And so to start us off, the objective of this particular class is to continue to work with Onshape, to get familiar with making models in Onshape. And some of the new concepts we're going to try to introduce are learning to use technical drawings. So looking at a drawing that someone else has made perhaps, and to create a model based on that drawing, rather than what we've done before, which is kind of looking at a model and kind of guessing some numbers, making the model look good. We'll also, towards the end, discuss a bit about the applications of CAD for manufacturing, and specifically, we'll talk more about 3D printing, which is something we didn't quite get to in the previous session. To give you an overview of the next 8 weeks, this is an 8-week class, so every week, same time, 8:30 to 9:30, we'll be meeting the first 3 weeks. So I did not update these days. You can ignore those. But we'll start off with just going over the CAD basics. So that'll be today. And in the first 2 or 3 weeks, we'll try to complete our first project, which will be our universal joint. So it's another kind of machine that I'll discuss in greater detail. And we'll start to look into using drawings and assemblies, perhaps for the first time. In the second kind of section of the class, we'll go into our second project, which is modeling a steam engine. So it sounds pretty exciting. You'll again be working with drawings and making models. And we'll go over some other topics like working with parts that like already exist that you have to modify, so kind of direct modeling. And in the last 2 weeks of the class, we'll be focusing more on manufacturing, 3D printing side, where the project will be you designing a keychain or some other thing like that. So in contrast to the previous class, we're going to have kind of a beginning section where I talk and demonstrate something, and another section where we kind of work on either one of the projects or some other CAD thing. So we're trying to move towards more independent modeling, which is kind of the goal of learning CAD. Outside of class as well, we'll have more like homework assignments between weeks. So for like the projects, you might be expected to complete a model by the next class, so that you'll have it to work with whenever we do the next part. So for example, this week there won't be a homework assignment, but next week the assignment will be to model the parts of the universal joint. So with that, let me know if you have any questions about how this class is going to go. As I've said before, some of you might not have been here, but you can message me in the chat. I see already there's a question in the chat, which I'll get to. Also, feel free just to unmute and speak up. It's a small class, so there's no problem with that. In terms of the Google Classroom, I believe there's a direct link to join in the email that you should have received where you got the Zoom link for this class. But even if there's not, you'll see that I posted like in the chat, I put in a code. I'll put it in there again in case you missed it. But in like the Google Classroom UI, there's probably a place where you can enter a code to join a classroom. So for this first week, it's not too important. Just try to get that done before the next week where we will be using the classroom. So you have some time to figure it out. But if you have problems, let me know. If there are no other questions, we'll get into it. Starting off with a bit of a review of CAD. So today we'll start off kind of just with a demonstration where I make something, you follow along. It's a bit like what we've done before, but the object that we're trying to achieve today is modeling this chess rook. So it's a bit more complicated as a single part than the parts that we've done before for our ellipse trammel, the do nothing machine, or the sprocket machine. We perhaps haven't had any single part that's as maybe as detailed as the chess rook before. So just starting off, I'll ask the classic questions like, how'd you go about this? What shapes do you see? And what on-shape features do you think you might use to make something like this? So take a moment, like look at your features, familiarize yourself with what we've done before, and I'd like to see some answers. Yeah, so first answer, someone says use revolve. I think that's a pretty good idea since the rook, for the most part, is pretty symmetric circularly. Yeah. So yeah, revolve is a good thing to do. You'll notice here though that the entire thing isn't quite revolvable, right? There's some features that are symmetric but not continuous when you revolve them. So what features might you use to try to make these square parts on the top? Maybe a cone for the middle. I see you're talking about kind of like the stem here, where you'd pick up the rook, like in the middle. Yeah, I can see how that would be a conical surface. I agree. Does anyone have any ideas for the top here of the castle part? All right, someone says extrude, which I'd buy. Yeah, so it seems like at least one of you has a pretty good grasp of the CAD tools that we talked about before, which is pretty promising. And we'll just get right into it. So the first step, as one of the students said, is to use the revolve. And I think that's a good idea. You can probably get most of the body of the rook using a revolve. So what I'd like you to take a moment to do right now, if you have a pen and paper, get your pen and paper. If you don't, you can just pull up like Paint on your computer or a similar program. But what I want you to do is draw the shape that you would revolve in order to get the chess rook when you revolve it. So I want you to draw like the axis of revolution that you'd use, and I want you to draw whatever profile you think you would need to make in order to result in the main body of this rook. So I'll give you a moment to try to do that. And maybe I'll have one of you share if you want to. I might call on somebody. All right. I'll give you just under a minute, and then I'll ask some people to show me what they think. All right, so I stopped sharing. I assume most of you use Paint, but if you have a picture on a paper, you can just hold it up to the camera. I guess, does anyone volunteer? Anyone really excited to show what they drew? How about Christopher? I'd like to volunteer you to share what you have.
I haven't really thought of much yet, so can you give me more time?
Sure, that's fine. That's understandable. I can come back to you.
Okay. Can you like repeat like what was supposed to do? Draw something?
Yeah, I just want you to draw, like either in Paint or on a piece of paper, the profile and the revolve axis that you think you'd make to get this kind of
Okay.
body shape for the rook. Yeah, I guess maybe I didn't give you enough time. I see someone in the chat also saying. How about Amy? Do you have something you'd want to share with us?
Yeah, I did like half of it
Okay.
here. This it's kind of like the top is like an upside down triangle and the bottom is the actual like triangle, and
Yeah.
it's kind of rounded.
And so where would the axis of revolution be? What line would you spin this around to make the rook shape?
I'm not sure.
Okay, that's fine. Yeah, I like the ideas here though. Like I know you said there's kind of a cone shape in the middle, so you have those like triangular lines. So I'll wait for one more person to share and then we can move on, try making this thing an on shape. So whenever you're ready, just anyone can feel free to share. How about Christopher? Have you had enough time?
So I got like a. If I'm gonna use a cylinder or maybe a cone, a part of a cone for the bottom part. And the middle part I use a cylinder, and the top part I use a maybe some. I don't know how to explain this. Do you know those things, the square things that go up that make it look like the.
Yeah, and I think that kind of brings up kind of an important point of note, which is that I suppose there is sort of a standard chess rook that's used for like chess tournaments, but for the most part, the chess rook is a pretty artistic object where the exact shape and size and such is up to the person who makes the chess set. So yeah, it's not really that important that we have any particular shape for the chess rook. So we could make a cylinder in the middle, it could be a cone. Kind of like the previous things that we've done, it's really up to us. And this is in contrast to some of the things we'll do later on, where it'll matter a bit more that we make things exactly to a specific specification. But I guess I'll show you what I think about this, and you can hopefully see my paint screen right now. So if I have my axis of revolution here, let me make my brush wider. I have my axis of revolution. I probably want the profile to be right up against the axis of revolution, since it's kind of a, like there's no holes in it that go through it. So you have the base here, maybe this stem part comes up here. This is the middle part of the chess rook, and then it comes out to the top. And you'd have something like that. So you can imagine that this goes straight up to the axis. So you can see my ability to draw in paint is not the best, but hopefully you get the idea. We kind of want to have this protrusion here, since in the real model, we can see that there is kind of a blind hole, a shallow kind of cutout from the center there. And then afterwards, we can try to extrude the castle things. So we'll put aside the drawing for now and go into Onshape. So hopefully you have this open. Just create a new part studio, probably in a new document. We're just going to use this for the rook, and starting next week we'll do something else. So I'd say just create a new document, create a part studio, and we'll get started. So first things first, we need to make a sketch. These are the basics of hopefully what you remember from the previous class. We have all our familiar tools, and I'll start off just by defining kind of this axis of revolution, so a vertical line. And I'll give it a dimension just so that my sketch knows generally what ballpark of size this is. Maybe an inch tall, a bit on the short side. And from here, I kind of have my idea in my head of what this should look like. I'll have this. I'll just slowly start tracing out the shape of what I want. So up to here, this square protrusion here is intended to be this part of the chess rook. Then we see that it kind of tapers down into the stem. So I'll make a line for that. Then in this particular rook, the stem kind of flares out, it gets wider, and then it comes to the base. So I'll just model that. And I'll finish off my profile. So I have something like that. All I've done right now is just draw lines and click and drag until I have enough segments to kind of make the shape that I want. And as I said before, this chesswork isn't really a technical machine component. It doesn't have to be in any exact shape to meet its usefulness. Like the chesswork will be useful as long as it vaguely resembles the classical shape that we expect. And what you'll notice that I did as I was doing this is I kind of wait for Onshape to give me these indicators. So you can see right now around my mouse, when I'm trying to make a line segment, if I hover and keep it in just the right place, Onshape will create constraints automatically. So if I hover in this exact position, you can see kind of to the bottom and to the right of my mouse cursor, there is the constraint symbol for horizontal. And so if I have that show up and then I click, this line segment will have the horizontal constraint automatically. You can see that there. And so I can make my life a bit easier for myself if wherever I know that I want a horizontal or a vertical line, if I just use those kind of assumed constraints, these implicitly made constraints. And so you can see that these lines in my sketch are already given the vertical or the horizontal constraint without me actually applying them. And that'll just make it easier for me to do the next thing, which will be to turn all the lines black. I need to fully constrain the sketch. So once you have this general profile, it doesn't have to be perfect. We'll get to adding dimensions and adding constraints until it's fully defined. So hopefully this is just an exercise for you and you're already pros, you already are confident and able to do this. But I'll just start from the bottom and work my way to the top, adding sensible dimensions. So I might want to control like the radius of my final base. Maybe the total height of the rook. And you can see that as you start adding dimensions, the shape is going to mess up a bit, but as long as there are blue points, you can still drag things around and nothing is really established. What we'll probably also find is that once we actually make this thing, it's probably not going to look the way we expect. And if that happens, all you have to do is go back and try to change the dimensions until it does. So that's the nice thing about not having any constraints. So see if you're able to fully dimension the thing yourself. If you are, that's great. And if you're not, remember the trick that we talked about briefly before, which is wherever you see a blue point, try dragging it around and see what degrees of freedom it has. They'll kind of give you a hint as to what you still need to do in order to fully dimension this sketch. So you can see for me that I still have these blue points. So the location of these needs to be defined, which I can do with dimensions.
What's the, like, which two lines? This one?
Right. I'm not. I guess you're talking about this one.
Yep.
Yeah. So there's a lot of ways that you can achieve that particular dimension. The simplest way is just to select this line segment, since it's the length of this line segment right here that you're interested in dimensioning. So you just click that and you can give it a number. But as you've probably found by this point, there's a lot of ways you can dimension the same kind of dimension. So I could have selected like these two lines. Let me just highlight them. You could have selected those two lines. You could have selected these 2 points. You could actually have selected this point and this point, and it would still work. So a lot of options there. This one might be a bit harder to do. There we go. So that works. The simplest way is probably just to select this segment though. And as I go through this, I'll notice that things don't look really good. Or I'm not happy with the way it looks. Might be a bit too tall. So you can work on that and just keep doing it until all the lines are black, which indicates that it's fully dimensioned. It's probably the hardest part of making the rook, just working with a sketch with so many lines. So when you get it, say something maybe in the chat or out loud. And if you have any problems, if you have any questions, feel free to ask and we can look at it together. Don't worry about making the exact same numbers I do. I'm making all of these up myself. So whatever you think seems reasonable is probably fine.
I can't get the right here to turn blue. I mean black.
Yeah, that one might be a hard one. In my case, yeah, there's a lot of different things that it might be. The main thing to think about is kind of think of it as like the hypotenuse of a right triangle. So you kind of want to define the width, kind of the base of the triangle, and you want to define the height of the triangle. So these two dimensions will fully define the length of this segment, and then the position of the ends will be determined by the other ones. So it's a bit tricky. See if you can get it, but also feel free to screen share if you want to look at it together.
I already did this,
Okay.
but it still doesn't work.
You want to see my very dreadful rook design?
Yeah, I can see something. So are you planning to revolve this?
Yeah.
Yeah, so make sure you have some axis of revolution. Where are you planning to revolve this rook to create the body?
Yeah, I don't really know yet.
Yeah, that's probably the first thing you should try to figure out if you're going to revolve.
Oh, okay.
Yeah. So the basic shape that you want is probably somewhat similar to what I have, but try working on that, and we'll take a look at Amy. Yeah, so something like this is probably what you'd want, Christopher.
This one is mine,
Okay.
but I just can't get these two lines to turn.
Yeah, I'd say you're almost there. I imagine what it is that the position of that point, the middle blue point, that's not fully defined. So you can probably click and drag that one around.
This?
Right, that point isn't fully defined. And what you probably need is a horizontal dimension for the position of that blue dot. So if you try to add a dimension.
How do you do that?
Pardon?
How do you add the horizontal dimension?
Yeah, so you can just add one like you have for all the other ones. Just use the dimension tool. You can press D on your keyboard. It's the same one. Just click that point and then click some other feature. So maybe like the vertical axis is probably one that'll work. You can also try to select one of the other points. Yeah, so in this case, you could try selecting like that point and
this
like,
one,
right, that one,
and
you could try clicking like the origin or the point above it.
this one.
Yeah, that one would work. So then try to bring your mouse so that you get a horizontal dimension. So right now you have like an angled one, you have a vertical one right now. If you bring your mouse down below the origin, below the origin, so more to the left. Yeah, you can see for a moment there, it was giving you a horizontal dimension. So kind of, if you have your mouse right there, yeah, that'll produce a horizontal dimension. And I think that'll make everything fully constrained.
Oh, yeah, it works.
Yeah, good to hear.
Thank you.
And so I guess to explain the concept, I guess it might not have been completely clear. So if you're like Christopher and you're kind of not sure about what the axis of revolution should be, I guess just in general, if you're not sure what the axis of revolution is, in my case, I'm trying to choose this as my axis of revolution. And if you don't remember the axis, the way it works is you take your profile and it's like you're just spinning this axis and you're sweeping the profile around, and all of the volume that gets enclosed in that sweep is kind of going to become your final solid shape. So this will become more apparent when I actually do the revolve, but for the most part, you're going to want to draw something like this. So I guess at least one person is at this point. Is anyone else here? They have a fully defined sketch that looks vaguely like this. Okay, almost there, I see. So I'll give you another minute or so. If you have questions, feel free to ask. That's why I'm here. We can take a look at it together. And once we do that, we can get into kind of the finishing touch, which is the cutouts in the castle head. And what you'll find is it's actually kind of hard to guess what the product will look like when you're just looking at this rotational cross section. It's easy to make things that are too wide or too thin, and it's hard to tell because maybe we're not used to projecting things into a revolved form. There's a good chance that I'll come back to the sketch and change it later once I decide that it doesn't look good. right, so I'll give you till 9:10, and at that point, you don't have to worry too much about it being fully defined as long as you have a shape like this. Like as we saw before, it's not going to not work if it's not fully defined, but the main objective in most times, you kind of want to have a standard shape that won't break when you change it, or that can't be changed. All right, so last call for questions. If you need help, just say something, and I'm totally fine with that. But if no one says something, I'm going to move on. All right, so you have something like this, and the next step, as you probably guessed, is to revolve it. That's why we did this. And if you recall from before, when we used the revolve tool to make things like handles for our machines, we need two things. The first of which is like a sketch region or a face. So in our case, that's this thing, which you should hopefully be able to select. And the second thing that you need is a revolve axis. And so as I've pointed out, the revolve axis is going to be this vertical line that goes through my z-axis here in this. You can only see what the axes are from the navigation cube. So I'll just select this line. And I'll leave this part as full, just the default settings, and it'll give me a preview that looks like this. So already I can see kind of what happened. It took my profile and it just spun it around my axis, and it kept all of that volume that it enclosed as my final product. The other thing you'll notice is that it doesn't really look that pretty. So I did not do a great job of picking dimensions that'll look good, but the good thing is that I can always change it. So you want to do that. If you have any problems with getting the revolve to work, let me know. And if you're like me and you look at this and you think this doesn't look quite how I pictured it, you can go back into your sketch. So in our feature tree here on the right, you can right click and edit, and you can try to tweak things to look a bit better if you want. So I think my base is a bit too wide, so I'll lower this maybe to 0.3. Okay, that's not too much, 0.375 maybe. I also think this part is a bit too sharply angled. I might lower that to 0.5, even 0.4 maybe. And maybe with that, I'll like it better. So still not great, but you can mess with it. I think 0.5 was a bit better. And if you have any questions about this part, ask. And if not, I'll probably move on in a minute or so, since I'm happy with my shape. All right, I don't see any questions, so I'll assume everyone has something that looks like this. If you don't, say something, but we'll go on to cut out some shapes from the top of the rook. So the way I'm going to do that is I'm going to look down, kind of a top-down view of my rook. And what I want to do is I want to sketch something onto this face that I've highlighted. I'm just going to sketch the shape of one of these cutouts, and I'll use that to extrude cut some material And so how can I do this? I'm not sure if we've used this. I think we did for the base of the do nothing machine, the ellipse trammel, but it turns out when you click the sketch button and it asks you to select a sketch plane, you can actually select any flat plane that exists on your model. So in my case, that's this one. And if I click this, you can see that my sketch plane here, where it says sketch 2, that's actually on top of the rook right now. It's not on my top plane, it's right there. So that is what I want because that's where I want to produce my sketch. So I'll just go back to my top view and I'll start sketching. And so the first thing I need, well, the only thing I need to do is sketch out the shape of one of these circular things, one of these cutouts. And in order to do that, I kind of want to reference what the existing part looks like. And technically speaking, there's nothing in my sketch right now. None of these things are really in my sketch right now. And what I want to do is bring it into my sketch so I can reference them when I'm making other sketches, making other lines, making other arcs. And the way that I can do that is using this tool here, which is called projector convert. It's right next to the construction line one. Looks like a cube with one segment highlighted. I'm not sure if I showed this in the previous class, but I'll explain it again if I did. Its function is to take any other part or other sketch that's not in your current sketch and to essentially bring it into your current sketch. So these circles right now, these are not in my sketch right now, and I want them to be in my sketch. So all I have to do is click on them. And you can see the lines get darker, right? That means they're in my sketch. So all I did was I selected this tool, this project convert tool. You can see the tool is highlighted and my cursor changed. And all I did was click on those two circles and it brings it into my sketch. And you can tell because the lines are dark now. So even if I hide the part, these lines are still there. These circles are still there. So hopefully that works. Next thing we're going to do, maybe this is bringing you back to the time we made this sprocket. We don't want to have to make every single one of these 5 or 6 cutouts by hand individually. We're going to take advantage of the circular pattern. But we're going to do that in a circular part pattern rather than a sketch pattern. So I'm only going to sketch a single cutout. And the way I'll do that is probably starting off with maybe a line like that. You can see that due to the vertical constraint, that turns black automatically. And I'll just draw one more like that. So I have kind of a slice of pie cut out. And the way that I'll define the second line, the one that's blue right now, is I'll just give it an angle dimension. So this one you might not have been familiar with. I don't think we use this too much. But if you select 2 lines that intersect or would intersect, so they're not parallel and they're in the same plane, then the lines will intersect. So they have some angle between them. And so if you just select those 2 lines that aren't parallel, the dimension tool is smart. It'll assume that you want an angle, which is true. And you can just type in any angle you want. So 20 degrees, maybe that's a bit small, maybe 30 degrees. I think that seems reasonable. So not too complicated of a sketch, but we did use a new tool, which is the project convert tool, to bring these circles into our sketch. And we're using an angle dimension. And what that gives us is it gives us this region. So I highlighted it, but that's what we're going to try to cut out from the rook. So if you have any questions with the sketch, please ask.
I noticed on mine there are 3 circles instead of 2.
Okay. So the 2 circles that you want are the ones that kind of outline this shape. So I assume.
Yeah, it's the when I press top, it's the bottom, like the bottom circle. That
One of these circles, you mean?
Yeah, the bottom one.
So it might be a bit, when you're doing the projection, you might have accidentally selected one of these, and you can see that if I click these, it does bring it into my sketch. So just make sure it'll be fine if there are more circles, I think, but you might want to turn them into construction lines just so you don't confuse them later on.
Oh no, I'm just when I go to the same size as the top, so then when I press top view, then the bottom circle also shows up.
I'm not quite sure that I understand what you're describing, so maybe you can share what you have and we'll take a look.
It's like there are 3 circles.
Right. Can you change your angle a bit just so I have an idea
Yeah,
of
I'm
the 3D?
saying I think it's the bottom, these circles are bigger than, so I do that.
Yeah, that's fine. So that big circle isn't actually part of your sketch. So like I said, when you start off, there's nothing in your sketch, and that's why we had to use the project and convert tool. So right now what you have is fine. If you're confused, what I'd recommend is if you go down to part 1 in the bottom left, in like the part, I'll show you. Here, there's an eye here. And so as you recall, you can hide things with the eye. And so if you're confused by seeing the part, you can just hide the part. And then the only things that'll be left is the sketch itself. So what you had there, the circles were the correct ones.
Okay.
And you can show the part again by just clicking the eye again. What you want to do, it's not necessary, but you might want to bring that line segment just to end on because it'll make it fully defined, but yeah. So with that, hopefully now when you exit the sketch, you confirm the sketch, click the green check mark, you see that you can select just this tiny region. And that's what we wanted. So what we're going to do, we're going to use the extrude tool to cut out that region. And I think you're familiar with that from when we cut out those trapezoid grooves in the ellipse trammel. So if I click extrude, it asks me to select a face, and I'll just select this little trapezoid face. And it's important that you actually select this whole like face, this whole shape area. Depending on how you did it, you might have cut it up. If you have extra circles that shouldn't be there, it might have cut up the trapezoid. So just make sure that you select all of these shapes that make up this region that I have highlighted. And what we're going to want to do is change it from add to remove. So that's kind of the second bar of options here, remove. And you can leave it at blind. And for the depth, you want to reduce the depth just so it doesn't cut too much like it is right now. I don't want to cut a whole inch, maybe 0.1 inches is reasonable. Yeah, for me, 0.1 might be reasonable. For you, it might vary, but that's all you need to do. The main thing is extrude. Make sure you select the correct region. You can leave it at blind. Make sure the direction is correct. You might see something like this and you might get this error message that it does not intersect. You have to press this arrow if it does that. Make sure the depth is reasonable, and then you can hit the green check mark. So again, this is something that we've done before, but for the first class, we're just gonna try to refresh everyone on the CAD, and we'll get into the new stuff in the following weeks. If you have any questions with this extrude, feel free to ask. You can see that when I accept it, I'll get my cutout and the sketch hides itself automatically. So we're almost there. From here, all we have to do is pattern this. And so the way we're going to do that, as we did for the sprocket, as you remember, we have something called the circular pattern. It's in the same place as it was before. You might have to use the drop down on the linear pattern one. But if you hit circular pattern, you're going to want to change it from a part pattern to a feature pattern. And the reason for that is because part refers to this whole solid object. Feature refers to something specific that we've done, like an extrusion. And what we want to pattern is this extrusion. So the way you can select it is just go to your feature tree on the left and click the extrude one that you made. For the axis of pattern, you can select any of the circles that are in this thing, since the circle is going to be centered. So I could click this circle, and hopefully it's nice. It wants to play nice and it works. Everyone's happy. You change the number to however many of these you want. Maybe 6, might be too many. Whatever pleases your sense of aesthetics. And having done that, you'll have essentially what is a rook shape. Now, I'll show that one more time just in case. It's a bit, it has been a while since we did a sprocket. So one more time, you change the part pattern to a feature pattern. To select a feature, you can just click on it on the feature tree. So I'll click on the word extrude one here on the left. For the axis, I can select any circular face. I can even select this conical face and I think it'll work. Yeah. I'm going to leave the angle, but just by default to 360 degrees. And I'll change the instance count maybe to 5. That's just my choice. And I'll leave everything else the way it is. And hopefully if the extrude worked, this works as well. And it allows you to do that. You might get some errors. And if you do, ask me. And if you did get to this point, let me know. Maybe put a message in the chat.
What did you say?
Pardon?
What did you say?
Or I just said, if you're at this point, let me know in some way. If you have trouble, also let me know, and we can look at it. But we are nearing the end of the class, which is 9:30. So yeah, so it seems like at least one person got it. Hopefully the rest of you are not far, or in the same position or not far behind. For the finishing touches, I'll introduce you again to our fillet tool. So I'm not sure if we use this. I think we did use this for one of the linkages in the previous class. So just remind you, the thing that this does is to round off corners. It turns corners that are sharp into corners that are round. And the way you can do it is you select edges like this one, or this one, or this one just by clicking on them. And what Onshape will do is just round them out with a circular fillet. So if you want to round off your corners, maybe that's a bit aggressive. You can change the radius as well. You can use that fillet tool. And if you're not happy with the shape, of course, the main thing to do is probably go back to that very first sketch and just change the dimensions a bit. So that concludes our little walkthrough of the work. The main objective of that was just to give you a refresher, make sure you remember how all the buttons work in Onshape, and hopefully you have something cool that you can show off in terms of this model. Since the class is almost over, I'll just give you a quick preview of what we're going to go into next. There's no homework for this week, so don't worry about that. I guess the only homework is if you don't have access to the Google Classroom, figure out how to get in here. I guess I can check who is. Yeah, so some people are already in here. The rest of you, I'm sure you're more than capable of figuring it out. The code is in the chat in the Zoom, so you can just put that into Classroom. And starting next week, we'll talk about drawings. So here is an example of what I mean when I talk about like a technical drawing or an engineering drawing. It's kind of like what you'd imagine in the conventional sense of the word drawing, but it's a lot more detailed. It contains information that allows you to replicate a model exactly. So if you're designing a product, if you're working with CAD, there are a lot of times where you want someone else to be able to create the same thing with a certain amount of information without actually sending them 3D model. So a drawing is how we do that. And starting next week, we're going to learn how to make things from drawings. So you can look forward to. Other than that, that's the end of the class. So thanks for coming. Hopefully you learned something. And if you have any last questions, I'll stick around just to address them. But beyond that, that's all there is. Let me just.
Thank you, Eugene. We can stop the recording. Can I stop or you can stop?
I was just about to do it, but I don't think I can.
Okay, let me stop it. Are you sure you want to stop recording? There's no access for you?